Retrieval Augmented Generation, or RAG, has been taking the AI world by storm. It's become the dominant way, really the preferred way, to get the superpowers of large language models merged with your private data. But there's been a problem for some of the world's biggest industries like healthcare and finance and government and telcos. These are regulated environments. They need enterprise-grade security, scalability, and accuracy when building a RAG pipeline. And that has not been really available right now. We've seen a lot of great Twitter demos, but that's not enterprise-grade. Until now. Today, we're going to show you techniques and technology that turn this on its head and make it possible finally to build RAG systems that have the scale, the security, even running on-prem and air-gapped on-prem that you need in an enterprise environment. That's on today's RAGmasters. Hello, everybody, and welcome to another edition of RAGmasters, a show about retrieval augmented generation. I'm Neil Katz, 20-year tech entrepreneur. With me, as always, my fantastic partner in crime? No, probably not, but my partner on this show, Daniel Warfield, a data scientist, a RAG engineer, and a phenomenal educator on all these topics. Welcome, Daniel. How are you doing today?
I'm doing great. And I'm super excited about this because I feel like we're finally getting past that point of the Twitter demo, past the point of just, hey, investors, look at me. We're getting to the point where actual products, things are getting made. And I think this is a tremendous step in that direction. What are we talking about?
Well, we're talking about enterprise-grade RAG, I think, is the envelope of it. And underneath the hood, really being able to run a RAG system in the most secure data centers, like be able to run a RAG system that could even be air-gapped from the internet. I'm talking about a RAG system that you could run in a submarine or a bunker or a bank, frankly, which has security profiles just as tight as the military environments. And, you know, the Twitter demos have been great, as you said, but that's not something that Citibank's not going to run a Twitter demo. The Department of Defense is not going to run a Twitter demo. And in fact, we just saw at our company at iLevel, we just saw an RFP, request for proposal, from Department of Defense that said, hey, we want to do RAG, we want to do complex document ingestion and AI, but it has to run air-gapped and on-prem because our documents are not leaving this building. We're not hosting them on your AWS managed service cloud. Forget it. That's not happening. So the requirements to get big industry in the game are harder. And we're going to talk about today how using our technology at iLevel called GroundX, we're able to help companies do this and able to really overcome those hurdles of enterprise grade. Security is number one. Scalability is number two. These are big organizations. And accuracy. If we could show the slides to the producer, I appreciate it. If the accuracy isn't there as well, especially on their complex documents, you can't really deploy this stuff. And that's why I think we've seen a lot more chatter than we've seen production level deployment. If you go to the next slide, we're grateful. Actually, I can do it. So these are like the industries that have been locked out, right? I mean, these are like the biggest industries in the world, right? These are the ones that, and I should say, have the most complex documents and could benefit the most, not just the companies and organizations, but their customers downstream. Like imagine how great healthcare could get, how efficient it could start to become if these language models plus RAG systems could be safely integrated into these businesses. So there's a lot of upside for doing this. And what we want to talk about today, frankly, is our technology. And I know this is a show where we talk about a lot of people's technology. Today, we're going to focus in a little bit on what we do here at iLevel. And what we're talking about is GroundX, our APIs for enterprise-grade RAG. And we've got a lot of customers already been running on GroundX. We're doing 2 billion tokens of ingest so far in this system. Companies like Air France and Dartmouth and many others. But what we're launching now is what we call GroundX on-prem, which takes this fundamental technology and allows you to run it in the world's most secure environments with enterprise-grade security, scalability, and accuracy. By security, I literally mean you can run an air-gapped in a submarine. No one's asked us to put it in a submarine yet. I hope they will.
Yeah, that'd be fun.
That would be an amazing assignment. But you can run it literally in these most secure environments. We've also built in scalability. And in a second, you're going to show us under the hood how all this works. We have our data shows, our research shows that we're more accurate than Pinecone at scale. This chart, the yellow guy on top is us. The two at the bottom there are Pinecone with LangChain and Llama Index. But the important thing is when you scale these systems, they start to lose accuracy in as few as 10,000 pages. That's not true with us. And we can auto scale to any workload because we're built on Kubernetes, which you're going to get to in a second to show you how we really do this. And then enterprise grade accuracy. We've done a bunch of videos about this in the past, but GroundX is built on a very unique ingest engine that we've constructed, built of a vision model that we've trained on 1 million pages of enterprise documents. Many of them look like this. And we have best-in-class document ingesting, and it can be fine-tuned for specific companies' needs, and best-in-class accuracy in part because of that. Those, I think that's table stakes if you want to play in the enterprise game. But I want to turn it over to you, Daniel, because I want you to, for the engineers out there, I'm kind of talking to business folks, to the engineers out there, under the hood, right? We're built on Kubernetes and fine-tuned open source models, which make this possible to be enterprise grade. But why don't you take us under the hood, explain what that really means, and how we handle CPUs and GPUs and workloads, and actually make this pretty simple to deploy, even though it's pretty complex under the hood.
Yeah. So, I mean, first of all, this ain't your collab RAG system, right? Like there's like a LangChain, Llama Index. You kind of, there's a bunch of like individual little tools that they grab and kind of put together to turn into like a, something that you can use in like a couple lines of code to deploy RAG. We have basically built the entire RAG pipeline within a single container. And I'm talking like the parser. And the parser is fundamentally different than other parsers. And the way we're doing querying is fundamentally different than everything else. There's a bunch of individual tools and technologies that we're using to create scalable and robust RAG. I'm not going to go into all of them in crazy depth. Just know that like in between all these like little nodes that we're talking about, there's a bunch of research in basically every single one of them. But from like a really high level, if we can show the slides, we have 2 services. And these are, Kubernetes services. We have the upload service and the search service. The upload service allows you to deploy documents or upload documents to a open search sort of database such that you can query against the information in the database. And that's what the search does, right? So you upload documents, those go in the database for search. Yeah. And then the search system, you give it a query, and then you get back sections of information that are relevant to, your document. That's what kind of like what these 2 different services do.
Right. Fundamentally, if you break down RAG at the end of the day, right, it's can you process documents? Can you turn human documents into LLM ready data with unbelievable accuracy? That's upload. And then when someone asks a question, can you search that LLM ready data and come back with really accurate retrievals at scale, and then pass it on to the language model, which is the last piece of the puzzle. Now, we're not a language model company, but you can plug this into any open source language model that you want to self-host, the Llamas, the Mistrals, and so forth. Or if your company or organization is comfortable enough with your contractual relationship with a Google or a Microsoft or AWS, as many companies are, you can still use those services as well.
Yeah, exactly. So we have these 2 services, upload and search, and that's the retrieval component of Retrieval Augmented Generation, right? Under the hood, this is all running in Dockerized microservices that can be deployed, that are deployable very easily via Kubernetes. So there's like a single unified API, and that's a microservice within itself that exists within a pod. And then we have these 2 subservices, the upload service and the search service, right? Yeah. And then we have different pods that are running different microservices. Like, for instance, when you upload a document and it's this complex PDF, for instance, you might have tables, and then over here a figure, and then down here a section of documents. One of the many things we do is we apply a fine-tuned Detectron 2 style model to your document to extract layout information, right? So that's one of these microservices. And then we also have different subservices for turning those individual layout things and splitting them across different processing pipelines. We have different microservices for extracting metadata from those things and building section and document level metadata so that we can construct contextualized. We have all these individual tiny little microservices doing a bunch of different stuff that you wouldn't really see in a, traditional RAG setup that you might deploy in, like, I don't know, Google Colab with like LlamaIndex, for instance, right?
For sure.
And then once we've turned your documents into these chunks, we call them semantic objects. But once you've turned these documents into chunks, then you can search. And there's a separate set of microservices that are used for that, right? So if you have a query, we do query rewriting so that it's your query is actually better in terms of search. We do semantic similarity. We also have a model that's hosted that does re-ranking. And all this exists within this tiny little Docker container. Well, they're not always super tiny. It depends, right? But we have all these within these Docker containers that then can be deployed via Kubernetes. Mm-hmm. And this is really important. These are all deployed across different node groups. So a node group is essentially a set of resource requirements that's required to run a particular pod, right? So the pods are like, you can kind of think of them as the microservices that are running. And then the node group is like, what computer are these microservices running on? And we define a variety of node groups that we use. We have some that are prioritized in terms of number of computational cores. We have some that unified prioritize cores and RAM. And those are just the CPU node groups. And then we have GPU node groups, some of which can run tiny models, some of which are designed to run very tiny models, but also need RAM for processing. So you're doing simultaneous CPU and GPU. And then we also have some node groups for rather larger models, such that, like our big, hosting an LLM for rewriting, for instance, right? So we have all of these node groups. And all of these pods are deployed across different node groups that are dependent on the thing that's actually being run within that pod.
Yeah, I think this is a really important point, because to do this correctly, to do this efficiently, and to scale it, you have to be able to understand which processes in your RAG pipeline are GPU intensive and which ones are CPU intensive, and how much memory do each one of them take. So document layout, the Detectron and document layout and understanding, for example, very GPU intensive. Search, CPU intensive. And the microservices, I'm saying it broadly, the microservices underneath that break that down even further. So if in a realistic world, if you want to build a RAG pipeline that scales and run and takes maximum use of the compute you have available, you need a layer that's going to figure out essentially how to distribute this correctly on the compute you have. And we've tried to make that very simple in how we help you deploy it.
Yeah, exactly. So all these microservices are talking to each other via Kafka, right? So they're still they're not separate things. They're still one thing, but we took the one thing of uploading and we subdivided it. And exactly for the reason Neil said, you have to be able to subdivide them so the CPU stuff can be running on CPU machines, the GPU stuff can be running on GPU machines. And really, you can kind of think of this is there's really two key benefits from a deployability perspective. And besides the fact that all of this is offline, right? Like that's
right. It can be. You can run online too. But if you want to be air gapped, that's finally available to you.
Exactly. So besides that, which is like that, we need that from a security perspective in highly regulated industries. Besides that, if you're actually going to stand a chance of actually using this, it needs to be deployed in a way that's efficient. So having all these things decoupled so that you can scale them independently, super important. And also having them all pre-configured is pretty freaking useful, right? Like this is kind of one of those things that it's like, you don't technically need to check it on a list. It's like, oh, I can configure it. But we spent 3 or 4 weeks deploying 100,000 documents in LangChain because LangChain had dependency problems, some of which it was using CPU dependencies when it should be using GPU dependencies. Some of these had complex dependency layouts that went down to like I think some of them down to almost the kernel level, like really low level runtime environments for parallel computing. Some of them were GPU, some of them were CPU, and LangChain had them slightly misconfigured. We had to dig through the source code of this open source system, something that just works. And we spent a ton of time to do it. And like it just straight up wasn't using the GPU for some applications. And even if you don't want to do that, right, having something that doesn't care about decoupling, if LangChain decides, hey, I need to do a CPU intensive process, then a GPU intensive process, and because it's all in LangChain, it's all running in this one sequential sequence, you're screwed. You need a massive machine that has a crazy GPU and a crazy CPU. You're going to be using the CPU half the time and the GPU half the time, and you're going to rake up a crazy bill out of nowhere for no reason. So having it be pre-configured so that it just actually works, and also decoupled so that independent things can scale independently without wasting resources from a scalability perspective is vital, frankly.
And from a headache perspective, right? These are like plumbing headaches that really this is not the fun part of building these applications, right? So, the test you're talking about, we didn't even see that coming, right? We were really just trying to test the accuracy at scale of Pinecone running through LangChain and Pinecone running through Llama Index. When we started to scale up to like 100,000 pages, we've even done it to 1 million, but the research that we published was only out to 100,000 pages. And we ran into this roadblock we didn't even see coming, which is if you LangChain with unstructured, which is the parsing APIs they use, it just literally fell apart when you tried to scale it past, I don't know, a couple thousand pages. I think you calculated that if we had just let this process run to ingest 100,000 pages with LangChain plus unstructured, that would have been 31 days of ingest. And so what we did is we just ripped it apart, and we're like, all right, I got to get down to the iron and try to start to assign the processes of this thing to GPUs and CPUs. But that was a week of work of config that was thankless work, not much documentation. How are you supposed to do any of that? Because no one does any of that with those things. So we realized, wait a second, there's actually some mechanical problems with some of the stuff out there, and we really spent a lot of time trying to eliminate that, actually, to make it pretty seamless. So that's not the layer of the problem that you have to work on when you're trying to build something for your enterprise.
Yeah, but is it seamless, right? Oh man, I have to deploy this thing on Kafka. If we can show the slides, to actually get this working, one command, 10 minutes. So if you already have Kubernetes set up and the correct resources for actually running these nodes, you need one command, and it'll deploy over the course of 10 minutes. And also, if you don't have a server sitting around that has a proper requirements, and you're allowed to use something like AWS, maybe you need it to be in your own VPC, but you can use the cloud. We also have a script that allows you to spool up the proper Kubernetes sort of system in AWS with one command, and then you can deploy GroundX to it with one more command. So it's really simple, and I'm really excited. We're going to be rolling out a few tutorials for AWS we have covered right now, and there's scripts for Google Cloud and Azure, Microsoft Cloud, coming out very soon. So if you have a local system, it literally needs to be in your submarine. We got you covered. If you have AWS and you have some VPCs you want to get rocking, we have you covered.
Yeah, and then once it's deployed, you can your engineers can call the APIs just like you would any other. They're just pointed internally instead of to our managed service over at eye level. So it's easy to deploy, but also really easy to pick up and start using as a real RAG system after that.
Yeah. And that's also what's kind of cool. It's like it also is on the cloud, right? So if you have some sample data and you want to play around with validating, is it worth to build a system locally?
Yeah.
Get some fake data that you can expose online and then play around. And then you can just be like, oh, this is great. Boom. Now it's local. Super easy.
Absolutely. All right. So I think that covers us for today, Daniel. I think in a future episode, we're going to get into under the hood even further and really geek out on how this stuff works and deploys. But I think this is a great overview for today. Good introduction to RAG on-prem, even air-gapped RAG on-prem for enterprise-grade deployments, which we think is actually the next generation of where this technology goes. So thank you once again, sir, for joining me. Everybody, thank you for another episode of RAGmasters hanging out with us. Like and subscribe. I'm always supposed to say it at the beginning of the video, but I always say it at the end. We'll see you next time on RAGmasters.